Welcome. In this video, we are going to find the work done in moving the gas, or rather in taking the gas from point A to B, point B to C, C to D, and D to A. Then the question that we've been given says, the figure below shows the PV diagram of a gas, of which we have been given this axis for pressure and this axis for volume. So from here now, the question that we are required to find is to use the graph in finding. So A, find the work done in taking the gas from A to B, then B to C, then C to D, as well as D to A. Then from here, we are also told to find the net work done. So from here, we need to understand something to say we have two categories here. We have got some lines that are having the same, or rather, we have these lines, and these lines. So for example, if we have the volume of 20 here, so all the values that are going to fall under this line, they are going to have the same value because they are isovolumetric. And in the same vein, these lines, like for example 200 here, so all the values that are going to fall under this line have the same pressure. The same applies even to this, and to this. And for volume, the same applies to this, and this. So these have the same pressure. So this line AB, the pressure is constant. BC, the volume is constant. CD, the pressure is constant, but the volume is changing. Then from here to here, DA, the pressure is not constant, and the volume is constant. So this one, constant pressure, different volume. So from this, I think from this basis, we are going to proceed. So we're going to find the solutions. The first question, find the work that is done in moving the gas from A to B. So work done A to B. So this is equal to the work done is given by the pressure delta V. The pressure times change in volume. So here the pressure that we have is from A to B. We have this, which is 200. Then times the change in volume. So the volume is changing from 20 to 50. So we have 50 minus 20. So this is going to give us 200 times 30. So what we're going to have is 6,000 joules. That is the unit for work. And so this one can also be expressed in terms of kilojoules by just saying 6 kilojoules. So this is the answer for the first part. And for the second part, the work done in moving this from B to C. So work done in B to C. So here we have P delta V. So here we have, so the pressure that we have, so it is changing from 200 to 50, but because of the same volume, but here we know that the change in volume is equal to 0, because we have the same volume here, which is 50. So V1 is equal to 50, and the V2 is equal to 50. So the change in volume is equal to 0. So 0 times P, what we're going to have is, we are going to have 0. So this is the value for the second. C to D. So the same formula applies. CD is equal to P delta V. So the pressure C to D, we have the same pressure, which is 50, times the volume that we have. So the volume is changing from 50 to 20. So the final will be 20 and the initial 50. So we have 20 minus 50. Okay, so from here we have 50 times negative 30. So here what we're going to have is, this is 15, so 1,500, so negative joules. Okay, so we can also express it in terms of kilojoules. So 1, 2, 3. Okay, so we have negative 1.5 kilojoules. So from here, what we're going to do is we are going to find the work done in moving the gas from, or taking the gas from D to A. D to A, the pressure is changing from 50 to 200, but the volume remains constant. So this line is isovolumetric. And what we're going to do is, so let me just erase this part. Moving from D to A, where we have the constant volume in this line, and the pressure is changing from 50 to 200 newtons per square meter. So from here, what we're going to do is, so this is the work done. So this is 4. So the work done in D to A is equal to P delta V. Now, the pressure is changing, of course, from this to this. Now, without even wasting time, we shouldn't even waste time because we know that this is the same volume. This is the same volume. It is isovolumetric. So the volume at this and the volume at this are just the same. So we're going to have, so P V2 or V final minus V initial. And this is the case that applies even to the ones that we've done. So we're going to have P times, if VF is equal to the V final, like in this case we have 20 minus 20, we're going to have the same, we're going to have 0 as the answer. So 0 times the pressure, what we're going to have is 0. So this is the value for the work done in moving from D to A. D to A. The work done is 0. Now, let us finally find the total work done, or the net work done. So maybe from here, let me just erase even this part. So the net work done, so that is part B. So the work net done is equal to the work from A to B plus work from B to C. So A to B, B to C, plus the work done in moving from C to D, C to D, plus the work done in moving or in taking the gas from D to A, D to A. So now let's just plug in the values. In the first one, from A to B, we found 6 kilojoules, plus B to C, we found 0, plus C to D, we found negative 1.5 kilojoules, plus D to A. So C to D, we have that one. Then D to A, we have 0. So from here, we can say 6 kilojoules minus 1.5 kilojoules. And what we're going to find from here is 4.5 kilojoules.